All right, let's take a look at section 5.5, performing function operations. And so today what we're going to look at are taking two functions and being able to add, subtract, and multiply and divide them together. Before we get started, let's take a look at one simple term right here, and that is the domain. And hopefully you remember that the domain of a function are values of x, or what we call the input. So let's go ahead and get started. The way things are written in your problems, you'll see right here, are under the operations of functions. And for addition, you'll see in parentheses right there, f plus g, and then of x, or times x. So when they say f plus g, you're going to take the equation or the expression for f of x. For in this example, they put 5x, and then you're going to add g of x to it, which is x plus 2. So now the key right here to these problems is always to make sure that you put parentheses around the terms for f of x and g of x. And so that when you add them together, you can hopefully not get the signs mixed up incorrectly. It's especially important when it comes to subtracting two functions, because remember, when you subtract, you got to add, or the idea is you add the opposite of everything of the second expression, which would be g of x in this instance. So we'll go over several different scenarios and show you how to do this. In the bottom right there, in the last paragraph, it says the domain of the sum, difference, product, and quotient functions consists of the x values that are in the domains of both f and g. And I have this highlighted right here in yellow. Additionally, the domain of the quotient does not include x values for which g of x is equal to 0. So what they're saying right here is, remember that in the denominator, or sorry, the domain of the quotient, which would be values of x, for which g of x equals 0. I don't know why I said it doesn't. All right, so let's go ahead and move on and take a look at some of these questions. So we want to do two things in these problems right here, in numbers 1 through 4. They say, first off, you're going to add f plus g of x, and secondly, you're going to subtract f minus g of x, and then also state the domain of each. So let's go ahead and do that. The first part right here is we're going to add the function of f and g. So I'll go ahead and start off right here. We'll put the first function down, and we have negative 1/2 All right, so we got negative 1/2 cube root of x. And then let's go ahead and add right here g of x, which is 9/2 cube root of x. Now, since there's only one term for each, you probably didn't need to put the parentheses, but I'll just do that right now as good practice, and that's because that's what I asked you guys to do as well. So I look right here and I'm like, well, I could add these two together because they have the same index and the same terms underneath the radical. So we got negative 1/2 plus 9/2, and that ends up getting us 8/2. And 8/2 ends up equaling 4. So let's see, this right here will simplify down to 4 times the cube root of x. And this right here, let's go ahead and write, is f plus g. And so f plus g of x right here is equal to f plus the cube root of x. The next thing right here, or the last part, is it says state the domain. Well, if you recall, remember, we're dealing with the cube root function. So hopefully, we've been working on this. Cube root functions, they look something like an S shape. So that means that this right here, the domain would be all real numbers. All right, and that right there is f plus g of x. So let's do the same thing, or continue on, and let's try f minus g of x. So we'll take f of x, and so let's take negative 1/2 cube root of x, and then right here we've got minus 9/2 cube root of x. So we're subtracting these two, so this time we got negative 1/2 minus 9/2, and that right there is negative 10/2, which will be negative 5. So this will simplify down to negative 5, and then times the cube root of x. All right, so now that right there is f minus g of x. Once again, the function is similar, except we have a reflection right here. So my domain right here, once again, is all real numbers. Now, there is one last thing that I did not do, and the question says to evaluate when x is equal to 1,000 in this problem. So let's include negative 1,000. And so you're going to need to plug in negative 1,000 into the equation, or each equation that we came up with, and then be able to simplify that. So we got 4 to the cube root of negative 1,000. Simplify that. Looks like you should get your answer of is negative 40. And then over here, when we include negative 1,000 for negative 5, cube root of negative 1,000. That right there, you should end up with 50. All right, so that's pretty much it with adding and subtracting your two functions. We could do another one right here. Let's take a look at number 4. All right, so we'll start off. We've got f plus g. So let's check that out. And we have right here, we got 5 to the 4th root of x plus 1. And let's go ahead and add right here, negative 3, 4th root of x minus 2. Okay. And so remember, we can only combine terms that are alike. So right here, I've got 5 times the fourth root of x plus negative 3 fourth root of x. I can combine those together and end up with 2 to the fourth root of x. And then right here, we take the 1 plus negative 2, and that right there ends up equaling negative 1. So we have went ahead and we simplified this. The question now says, let's go ahead and evaluate when x is equal to 1. And that right there ends up equaling, the fourth root of 1 is 1, times 2 is 2, 2 minus 1 is 1. And there you go. Now let's think about our domain here. Because in this function, it moves up 1 unit right here, and it does something like that. That's kind of the basic idea. So you have to think, for my values of x, what would be my domain? And remember, it cannot, this one is not all real numbers because it does not go infinitely towards the negative. This one right here, x is going to be greater than or equal to 0. We can include 0 and everything that is greater than that, and that will be your values of x. All right, so for the next part, let's take a look at f minus g. And so over here, I've got 5 times the fourth root of x plus 1. And then we are going to subtract negative 3 times the fourth root of x minus 2. So things get a little bit dicey here because of the negative. Make sure, once again, I like to change the signs because when we're subtracting, we add the opposite. So right here, that change this to plus, and then we change the signs of everything on the inside of the parentheses. And then that usually makes things a whole lot easier when we simplify. So I got 5 times the fourth root of x plus a positive 3 times fourth root of x. So right there, we end up with 8 fourth root of x, and then 1 plus a positive 2 now, and that gets us 3. We'll go ahead and plug in 1 in there, and this time around, we end up with 11. What's my domain? Well, this time, instead of starting at positive 1 for y, it's going to be up here at 3, and it does kind of the same idea, right? So that means my domain should be pretty much the same, where x is greater than or equal to 0. All right. Now that we have that, let's go ahead and take a look at number 5. Now we're going to look at how we deal with functions when we multiply and divide them. So right here on number 5, we've got f of x is negative x to the third, and g of x is 2 times 3 rad 2. So we've got f times g right here. Now, if you look, one is in exponential form, the other one is in radical form. So the easiest way to do this is change it both to either radical form or change them both to exponential form. You take your pick. Either way you do it, should be perfectly fine. I think it's probably easier right here. I'm going to go ahead and change everything to exponential form. So what this is f of x right here, which is negative x to the third power, and g of x right here is negative 2 cube root, or sorry, I didn't change that at all. this right here, let's go ahead and change that to x to the 1/3 power. And so we're multiplying these two together. Remember, when you're multiplying, you add the powers. So you got to do a little bit of work right here. Add things up. We get common denominators. And so we'll have to put like that 3, put it over 1, and then multiply top and bottom by 3. And so this right here, let's see, how do I want to do this? We got 3 plus 1/3, and then let's get our common denominators. And then remember, we'll put this over 1. We'll have to multiply top and bottom by 3. So we'll end up with 10 over 3. Right, so let's go ahead. This will simplify down to positive 2 times x to the 10 over 3 third power. All right. So right here, last step is you plug in negative 64. And when you plug this into your calculator, you've got to make sure parentheses are critical, or else it's going to be bad news for the signs. Okay, so you're not going to get the right number. So 2, and you'll plug in negative 64 to the 10 over 30 third power. And you may even have to put parentheses in the exponent as well. All right. So if you're not going to get this answer, and you should practice it right now, so you can make sure you get it, use your calculator, you should end up with negative 2,097,152. So I definitely recommend that you practice using your calculator to get this number right here. All right, so that right there you have is f times g of x. And so you evaluated, last thing, what do we end up with? Remember, this right here is the cube root. Right, if I were to rewrite this, I would end up with the third root of x to the 10th power. Okay, so if we have the third root, then it's that S shape, telling me that my domain right here will be all real. So the last part to this problem, we're going to go ahead and take f of x, and we're going to divide that by g of x. So let's take right here, let's do f over g. I'll go ahead and write it right there. And we have negative x to the third. And let's go ahead and change this to 2 times x to the 1/3 power. And so remember right here, what we end up doing is subtracting the exponents, because that's what happens when you divide. So I'm going to end up with, we'll put negative x to the third minus 1/3 this time. And then we'll put this all over 2 because, well, we have a denominator of 2 and we can't just move that out of nowhere. All right, so we'll put all of this over 2. So let's put up here, I'll do a little math for you once again. Let's combine, let's get our common denominators. Put this over 1, but then we'll multiply top and bottom by 3, right? So it'll become, they have a denominator of 3. So this time we have 9 minus 1. So that'll be 8. And so what I'm left with now is x, or negative x to the 8 over 3rd power divided by 2. All right. So same old stuff right here. Now that we simplified this, let's go ahead and plug in 4 into your equation. Now let's see what you get. When you plug in 4 for x, or sorry, I'm looking at the wrong problem. When you plug in negative 64 for x right here, looks like you should end up with negative 32,768. All right, and there you have it. Now, one last thing right here for our domain. I want you to think. We have ourselves the cube root. That's good. We realize that's an S shape. But you have to remember this. On this problem right here, I have a variable in the denominator. Technically, I cannot have all real numbers because if I have 0 in my denominator, what ends up happening? If I were to take negative x to the third, or actually, let's go ahead right here. I'll plug in 0. And even without doing anything, you should realize, hey, in my denominator, 2 times 0 is 0, or 0 to the 1/3, 0 times 2, 0. Or sorry, 0 to the 1/3 would be 1, times 2 will be 1. But then what happens when I have 0 over 2? Does it end up being 0? What ends up happening here? Actually, sorry, let's go back one step. Actually, let's take a look right here at this part again. If we do our order of operations down below, we have 0 to the 1/3 power, which ends up equaling 0. So 2 times 0 is 0, but the problem is I have 0 in my denominator. And what does that mean? 0 in the denominator means no solution. So therefore, my domain cannot be all real numbers. My domain right here ends up being, we could say, is all real except x cannot equal 0. And there you have your domain. So especially when it comes to dividing, you've got to remember that we cannot have 0 in the denominator because that gives us no solution. If you plug it into your calculator, you're going to get an error, or it'll say like it just messes up. So keep that in mind. There is a reason why your computer may, or your calculator may say error, or just be like domain error or something like that, because of that exact reason. All right, so you have a pretty good idea now of multiplying, dividing, adding, and subtracting functions. And there is 5.5.